Hi everyone, in this video we are going to discuss volume by slicing. So let's have the first example. But first we recall what's the formula for the volume of a solid by slicing. So if you're using vertical cylinders, then the volume is simply equal to the definite integral of the area in terms of x dx from a to b. And if you're using horizontal cylinders, then V is equal to the definite integral of A, or the area, in terms of y dy from A to B. So we now answer this problem. Find the volume of the figure shown where the cross sections are circles, using volume by slicing. Okay, so first, observe that this solid is bounded on the left by the plane x equal to 0 and on the right by the plane x equal to 2. So again, here you have x equal to 0. Here you have a plane x equal to 2. And according to the problem, their cross sections are circle. So ito yan. Okay? So anong gagawin natin? So take note that the area of a circle is equal to pi r squared. Okay? So how do we solve for r? So kung ito yung circle natin, ito yung r. But take note that r is half the diameter. So kunin muna natin yung diameter, then we divide it by 2, so we get the radius. So how do we solve again r? So again, upper minus lower. So the upper curve is y equal to x squared. So that is x squared minus yung lower, which is negative x squared. So minus negative x squared all over 2 to get the radius. So this is equal to 2x squared over 2, or simply x squared. So the radius of this circle here, the radius of any arbitrary circle here is x squared. Okay? Of course, for x on the interval 0 to 2. Therefore, the area of the circle is simply equal to pi x squared, which is equal to pi x to the 4. Of course. So we can now compute for the volume. So the volume is equal to the definite integral of pi x to the 4 dx from 0 to 2. So this is equal to, this is easy to solve. This is pi x to the 5 all over 5 evaluated from 0 to 2. Which is equal to 32 pi all over 5 cubic units. For the next example, we want to find the volume of a sphere of radius r using horizontal slices. So in a way, we want to derive the volume of a sphere using the method of slicing. We want to show that the volume of the sphere is with radius r is equal to 4/3 pi r cubed. Okay, so that's what we want to show. But how do we use this? How do we use volume by slicing to derive this formula? Okay, similar to the previous example, note that the cross-sectional area of a sphere in a plane perpendicular to the y-axis for any y from negative r to r is a circle. Okay, so again, the area of a circle is equal to pi r squared. Okay? So, nasan yung r dito? Yung r dito ngayon ay from this point up to this point. So, yan yung r. So, let's call this point here xy. So, kung ito ay xy, this r here is x, and ito ay y. Okay? So, since we are using horizontal slices, dapat when we set up the volume, it must be in terms of y. Okay? So, we need to find r in terms of y. Okay? So, paano natin yung kukunin? So, from this figure here, kulang lang tayo ng isa para magkaroon ng right triangle. So, ang gagawin ko is to connect this to this point. But take note, this is a radius. So, ano ang measure nito? So, the measure of this line here is capital R. So, how do we find the value of the radius? Okay? So, by Pythagorean theorem, alam natin na ang r squared plus y squared equals capital R squared. So, this means that r is equal to the square root of capital R squared minus y squared. Thus, the area of a circle is equal to pi times square root of capital R squared minus y squared, or this is equal to pi times the quantity r squared minus y squared. Okay? So we can now solve for the volume of the sphere. So V is equal to the definite integral from negative r to r of the area, which is this. So that is pi quantity r squared minus y squared dy. This is dy since we are using horizontal slices. Okay, this is now equal to pi r squared y minus y cubed all over 3 evaluated from negative r to r. But take note, this is easy to compute. But this is equal to 4 pi r cubed all over 3 cubic units. Okay, so we derive the volume of the sphere. Okay, so that's it for this lesson. Good luck and thank you.